Today we're going to be starting with artificial intelligence. So this is the first video in a very long time. It's almost been a year. So let's get started. The first thing that we're going to be looking at is graphs. So this particular video is going to be all about graphs. Okay, whatever you need in the syllabus, we're going to cover that. Okay, first thing, let's look at the syllabus. Okay, so graphs can be used to aid AI. Okay, we need to know the purpose, the structure. Okay, and for searching in a graph we use A star and Dijkstra algorithms. Okay, now you will not be required to write algorithms to set up, access, or perform searches on graphs. Okay, so that is not required. Okay, so let's first understand the chapter using a mind map. Okay, so when I show you this, you won't understand the terminologies like instantly. Okay, this is just the basic. Okay, this is the structure. Okay, this is the outline. So I would request all of you to take a screenshot or write this. I would highly recommend writing this. Okay, so draw this mind map, write all the terms. Okay, first thing is artificial. Oh god, I wrote artificial neural network. I am so sorry. This is supposed to be AI. Okay, so under AI we have graphs in AI, then we have the purpose, the structure, searching algorithms, A star algorithms, Dijkstra algorithm. Okay, then we have machine learning, supervised learning. Okay, under machine learning, then unsupervised learning, reinforcement learning, regression. Okay, deep learning, and under deep learning we have ANN. Okay, now this ANN is actually inspired by the brain, and we also have back propagation under uh, deep learning. Okay, so these are the terms. Today we're only going to be focusing on graphs. Okay, so let's get started. So the purpose of graphs, basically, if I have, like, let's suppose that I have name. Okay, and I have address. Okay, now these are two entities. Okay, but there is a relationship, right? The relationship is this. Okay, so this is the relationship. Okay, so what is this relationship called? That is called an edge. Okay, and what are these things called? These things are called nodes. Okay, so these two terms you have learned, right? So you can actually create a graph by relating two different entities. Okay, using nodes and edges. Okay, so this is what you need to understand. So if I have A, B, and C, if I need to connect all of these entities, okay, nodes, I need to use edges. Okay, so A is related to B, B is related to C, C is related to A, and vice versa. Okay, so if I need to find B, okay, so let's say I'm going from A to C. Okay, A to C, and I need to find B. That means I'm currently over here. I can go back using back propagation, or I can use a searching algorithm, right, using A star or Dijkstra, and I have found B. Okay, so this is found. So these are the basic things that you need to know about graphs. Okay, so it provides a relationship between entities. AI problems can be solved by finding a path in the graph. Okay, so whenever we hear in the news that AI has solved this paper, this problem, or whatever, it uses a path in the graph. Okay, it solves the problem using a path in the graph. Okay, then we have searching algorithms, A star and Dijkstra. Now these searching algorithms are used to find the shortest path between two nodes. Okay, the shortest path, and we know it uses nodes and edges, right? Okay, so under the purpose and structure of graphs, we have A star and Dijkstra algorithm. Okay, now in A star, we need to find the better path using heuristic function. What is heuristic function? Okay, before that, let's look at better path. What does better path mean? Better path could be the shortest path. Yeah. So it uses heuristic function. Now heuristic function estimates the distance from the current position to the goal, and Dijkstra algorithm explores all possible routes. Okay, now these are two past paper questions. Okay, this is very important to understand, so let's look at this. Okay, so we need to find the shortest path between home and school nodes using A star algorithm. Show your working in the table provided. So usually A star algorithm is considered easier than Dijkstra. Both of them are pretty easy according to me. Okay, so let's start. Now remember, in A star we are using a heuristic function, meaning it is estimating the distance from your current node to your goal. Okay, so that distance it's estimating. So for example, if my goal is school, then home to school is going to be 14. And if you look from D, right, D to school, it is only 6, the heuristic function. Okay, how do you find out the heuristic function? Heuristic function is here. Okay, so these are all heuristic functions. Okay, these you need to understand. Okay, so let's get started. Okay, so home to school, that is your goal. Home to school, I need to find what? The shortest distance. Okay, I need to take a good path. Okay, so currently I am over, oopsies. Currently I am over here. Okay, I am at home and I need to go to school. Okay, so at home, my node is home. Cost from home node is 0. Okay, that means I have not traveled at all. I am still at home, and heuristic is 14, which is this. Okay, and total is, I'm going to add the cost from home node to and heuristic. So 0 plus 14 is 14. Now I can go to A. Okay, so if I go to A, then what will happen? Okay, let's try to understand. They have filled a few of them. Okay, so just 2 rows. So the cost from home node is 1, heuristic is 10, right? Total is going to be 11, so 1 plus 10. Now let's go to B. Okay, so B, so home to B, so cost is going to be 5 and heuristic is 7, and I need to add these and I'm going to get 12. Okay, now let's go to C. Let's see how it is. Okay, that was a bad joke. Home to C, which is 4, and we have 9, and I will have 13. Now which one is the shortest in your opinion? Which is the shortest total? The shortest total would be 11, right? Okay, so I have decided that I need to go from here. Now A is connected to E, A is connected to B. Okay, it is also connected to home, but home we have already understood. So I'm going to do A to B. Let's do A to B. Okay, A to B. So that is going to be 3, right? So 3 plus 1, which is 4. Okay. Okay. Why 4? Understand this. So I'm going like this, right? So I have gone to, let me take a different color. Let's take this color. So home to A, which is 1, A to E, A to E, or A to B. So 1 plus 3. So this is going to give me 4. Okay. So 4 I am getting. Okay. Now, what is my heuristic function? My heuristic function value is 7. Okay, so 7, and that is going to be 11. Okay, now I can also go to E, right? So that is going to be 1 plus 6, which is 7. Okay, heuristic is going to be 3, and total is going to be 10. And now which one is the shorter one? It is this, right? So I'm just going to tick this one, A and E. Okay, then I will have from E, right? From E, it's going to which paths? F, it is also going to school. Okay, so E to F. Okay, let's see. So if I want to go to F, then what do I have to do? Let's see. So 7 plus 1, which is 8. Okay, 1, which is going to be, and then heuristic is going to be just heuristic 3. So 8 plus 3 is 11. Now I can go to school as well. Okay, so school is going to be 7 plus 5. 7 plus 5 is 12. And heuristic for school is 0. I am not given it. And I also have 12. Now school. Okay, so I can go to F to school. That means it's going to be 8, right? 8 plus 3, which is 11, right? And heuristic is 0, so I'm going to add this, and yeah, so school is the shortest over here, right? So I actually went from F to school, right? So this and this. Okay, so try to solve this yourself. Now what is the path that we have established? Home, B, then E, then F, then school. Okay, so this is what we have established. Okay, so this is A-star algorithm. Okay, so I will give you another question for A-star algorithm. Okay, so you can do this yourself if you have understood the topic properly. Okay, it's pretty simple. 9618/32/m/j/23. So you can solve this paper as well for question 10. Okay, 10B. Okay, so you can solve this. So now we're going to be looking at Dijkstra algorithm. Dijkstra is very important. It is also slightly complicated, so do understand that. Okay, do understand that. So let's get started. Okay, so we again need to find the shortest distance between start and each of the destinations in the diagram using Dijkstra algorithm. So look at how it is. Okay, so we need to find A, B, C, D, E, F. Okay, so if I go from start to A, that is 8. Okay, if I go to start to F, that is 10. Or is that the shortest distance, or is that a shorter distance? Is that a shorter path? Right, so that is this is the question that we're actually asking. Okay, so how do we find the shortest distance between different nodes? Right, we are using Dijkstra algorithm. Basically, we're looking at all the possible routes. Okay, so the first thing is I want you to make a table. So this table is very important. Okay, make sure you write down your answer in the table that is given over here. Okay, we're going to be using another kind of table to do the working. Okay, so now let's look at this. Okay, so I've made a table over here. Okay, it looks better. So from base is going to be my start. Okay, my start. So the distance between base and base is 0. Okay, now now the other distances I don't really care, it is going to be infinity. Okay, now what is the shortest distance? Shortest distance is base only. So what I'm going to do is I'm going to write base. Okay, so this is done. Okay, now the next one is I have an option to go to A or F. Okay, let's go to A. Okay, let's go to A, but I will not write it. Oh, sorry. 1 second. I will not write it. We'll figure it out. Okay, so let me go to A. Okay, so what is the distance? It is 8. Okay, and the rest all are infinity. Okay, once I have boxed this, I cannot write anything here. Okay, this is not allowed. Okay, so what is the shortest distance from here? 8. So the shortest one is A, base, as marked. Okay, now next one, let me do it with this thing. Okay, the next one is I can go to F as well. So what is the distance for F? F is 10, right? 10. And the other distances, let's see. Okay, sorry, I made a mistake over here. So actually we should write 10 here itself, because I can go directly to start to F, right? The shortest distance is still 8. Okay, so now I cannot write anything here as well. Okay, so nothing there. Okay, now let's see the next one. Next one is, so I know that I can go to A. So from start to A, now I can also go to B. Okay, so B, let's see, that is going to be 4. So 8 plus 4 is 12. Okay, is there any other place where I can go? No. There is still 10, so I will write that. The shortest one, F. The shortest one is 10, so that is F. So I can keep marked as F. Okay, now the next one is, so I cannot write anything here. Okay, so let's see. So after 10, so I have gone literally like this. Okay, so let's see the next one. Let me go forward after B. So B is going to be D now. So let's see. So that is going to be 12 plus 2, which is 14. Can I go like that? Think about it. Okay, we actually need to go backwards because we have done this. So I can go from start to F. Okay, then F to something. So I can go to E or C. Okay, so if I want to go to E, let's think about it. So 10 plus 7 for E, so that is 17. Okay, then 10 plus 9 for 19, C. Okay, and this one we can. Now what is the shortest distance? Shortest distance is 12, right? So I can go to B. Now B, I'm over here, right? I can go to D or C, right? So if I'm over here, D, D is going to be 12 plus 2, which is 14, okay. Now B to C, so 8 plus 12, which is 20, okay, 20. Okay, so we also have 17. So what is the shortest one? The smallest one, it is 14. Okay, then okay, so we cannot access this, so I can write D as marked. Okay, now we have C and E remaining. Okay, so I am currently at D. Okay, I can go to E. Okay, and that's all. So this is going to be 20. I cannot change it over here. For C, okay, it's going to remain the same. Now for E, this is going to be 14 plus 2, which is 16, right? So the smallest value is 16, so I can keep this as marked. So E. Okay, then we have the next one, which is, I'm currently over here. I can go to C or F. Okay, C or F. C is already, C is not done. Okay, so 16 plus 3. 16 plus 3 is 19. Okay, and everything else is done. So this is the shortest distance. So I'm going to say this is C. Okay, so I now know that A is 8, okay, B is 12, and C is 19, D is 14, and E is 16, and F is 10. Okay, so yeah, this is it. Okay, so it's a little bit confusing for Dijkstra algorithm, but once you practice it again and again, it gets better. Okay, so this working, right, the working over here, you need to show by drawing this table. Okay, so just remember that. Okay, I will tell you another past paper that you can practice for this topic, and that is going to be this one. The first paper, so 9618/31M/J/21. Okay, so you can solve this paper, and that is basically it, guys. Okay, that's it. Hope you understood the topic pretty well. We will start with the other chapter, the next topic. Okay, and after we're done with the AI chapter, we'll go to the next one. Let me know if this video was helpful. Thank you so much. Please subscribe to CS Lobby. Hit the like button. Share this video if you found this helpful. Do all that jazz. Okay, goodbye.